On number 6, I'm trying to solve this equation, and my first step is to move the sign on the right over to the left. And then what I want to do is I want to factor this. So these are my two terms, and the GCF that's common to both of these terms is a sine. So I can factor out a sine, and that leaves me with a tangent of theta in this term, and then a minus 1 in that term. And the reason why I want to do that, if we look at, like, I guess a corresponding problem in algebra, which would be very similar, would be like if we have x squared plus 3x is equal to x. We don't divide by x here, and that's really why we don't divide both sides by sine here. So you don't want to divide by sine to get rid of sine. You want to move everything onto one side. Just like on here, you don't want to divide by x on both sides. You want to subtract x to the other side and have x squared plus 2x is equal to 0, and then you would factor out x. X plus 2 is equal to 0. So do not divide by x. You want to move everything to one side and then factor. So that's why I don't divide by sine. Okay, so I need to set both of these equal to 0. So sine of theta is equal to 0. Tangent of theta minus 1 is equal to 0. So tangent of theta is equal to 1. Okay, so let's look at sine of theta equal to 0. Sine is the y values. So where are my y values equal to 0? That would be here at 0. And that would be here at pi. So 0 and pi are two answers coming from this branch of the problem. Now, where is tangent equal to 1? Tangent is y over x. So you're kind of looking for where is y over x equal to 1. So you're really looking for where are your x and y values equal to the exact same thing. And that's going to be here at 5 pi over 4, as well as pi over 4. So square root of 2 over 2 over square root of 2 over 2, and then the negatives of that. So pi over 4 and 5 pi over 4. So these would be your four answers: 0, pi, pi over 4, and 5 pi over 4.